Hey guys, my name is Amit Chauhan. Uh, I've been working at Yugabyte for about 3 years now. Today we will be talking about resilience and like uh, how Yugabyte achieves it. Uh, Before I go into the agenda, the part of the reason I joined Yugabyte was the ultra resilience it offers to your applications. Before coming here, I was responsible for building applications which were always on kind of applications. Like they will be, if and this was at my previous company Verizon. If my product was down for a few minutes, like our network engineers, RF engineers, they were technicians, they were kind of blind to what's going on with our wireless network. So let's get started. I have a pretty packed agenda today. Uh, Today's application, as you know, they are cloud native. We'll look into common problems that happen in the cloud. We'll see how Yugabyte has been designed for cloud native applications, understanding how we can seamlessly handle zone failures, region failures, and you might have to apply new software or upgrade to your machines. So we'll see how you can do this without any service interruption. So we'll also discuss how we can be prepared for other kind of failures. So we'll go in detail on that. And um, first, to get some definitions out of the way. So what is resilience? The way I see it is its ability of a system to readily respond to or recover from changes, disruption, or a crisis. And modern applications demand ultra resilience. Customers expect always on apps, nations runs on digital infrastructure, and a brand reputation is all like requires 100% uptime. So we'll touch on some of the cloud issues, like what kind of issues can crop up when in your cloud environment. And as you know, cloud native applications are elastic and need to scale horizontally to handle varying workload. Resilience enables application to adapt the changes in the load. Virtual machines are respond on commodity hardware, which can disappear anytime. And although public clouds have come a long way since the inception of AWS, region and zone outages are still fairly common. So to provide uninterrupted service to your users, your application needs to be resilient to the failures. And high loads can cause power surges. Backup generators have failed too. So there are different resilience strategies such as load balancing, redundancy, and ensuring that users can access your service even if one region experiences issue. So let's talk a little bit about the fault domains. It's very important to understand different fault domains. And for example, various infrastructure components can fail. Disk failures, as you know, are very, very common. Nodes, zones, or even whole regions can fail because of multitude of reasons, which includes network or power outages. And so apart from infrastructure failures, there are many planned events where you might have to take down your application. For example, you might be doing OS upgrades or database upgrades or your application upgrades, right? So you need to be prepared for such scenarios. And it's very difficult to measure resilience as it's dependent on so many different factors. But the tech industries has settled on two concepts, RTO and RPO. So RPO is recovery point objective. Refers to the amount of data loss that has happened when a system recovers from an outage. And RTO is a recovery time object, refers to time taken for a system to recover after an outage. As we go on, we'll see how Yugabyte DB ensures no data loss for most scenarios with very, very small recovery time. So let's look into why we need to rethink resilience in today's cloud world. If in the case of traditional single node databases, replication had to be set up separately. You can deploy, for example, looking at this diagram, like Oracle in one zone and set up a standby in another zone for achieving high availability. You could deploy your observer servers in, for example, in zone B that replicates via Golden Gate or Active Data Guard. So this is asynchronous replication, and your data could be stale if you have to fail over. So RTO comes into play in here. And this is the same scheme if you have to deploy in one region or across region. Similarly, you could set up Postgres with bidirectional replication, and this also has similar issues as Oracle. So the key thing to note is that your application has to connect to primary instance and fail over to a standby as needed. So now let's talk a little bit about Yugabyte DB. It has been designed from ground up to solve such problems seamlessly. And it can be deployed across different zones and across regions in different patterns. I call it like art of possible with Yugabyte DB. And Yugabyte will guarantee that there is at least one other copy of data that is up to date for a no data loss failover. Also, your applications can connect to any node to access any data. So all your nodes are working equally hard for your application. And your app doesn't need to worry about which is primary, which is a standby. It's all seamless to the application. So let's go through a quick overview of how Yugabyte DB is able to accomplish this. What we do is, like in Yugabyte DB, when you create a table, so the data is split and is stored into multiple tablets. Think of tablets as like a shard or group of rows. And each row is mapped to one specific tablet. And all the nodes in the cluster know exactly where a specific row is stored. So this process is known as sharding. And this is all automatic. And these tablets are in a balanced fashion spread across different multiple nodes. Each tablet has multiple replicas. In this example, like I have RF of 3, so there will be two more copies of each tablet, and it has a leader that is primarily responsible for the data serving. The other replicas are called followers and get data replicated from the leader. When an application does a write, it goes to the leader first. The leader then replicates the write to multiple followers and waits for the quorum. And only after this write is acknowledged to the client or to the application. And for achieving this, we use Raft consensus algorithm to ensure that data is replicated properly. And we'll see in further slides how this enables applications to fail over seamlessly without any data loss. So let me explain how Yugabyte DB behaves on zone or node failures. Zone failure is effectively a failure of multiple nodes. And let's consider in this diagram, you will see 3 zones, single region, multiple zones. And here we have 3 different nodes sitting in each of the zone. And this is RF3 setup, which means that there will be 3 replica of each tablets, 1 leader, 2 followers. The solid circles in these diagram, you will see that they are leaders, dotted ones are followers, and leaders and followers are distributed across the 3 nodes, which are in 3 zones. So app can connect to any node to retrieve the data from this cluster. And let us say, for example, this on a given day, the zone East 1B, middle 1 fails. And now all the nodes in that zone becomes inaccessible. So the leaders in that zone are not available. And the connections to these nodes in that particular zone will start timing out. And all the nodes keep hard beating each other to check if the nodes are alive. It happens twice every second. And so within 3 seconds, the system elects new leaders for the tablets that originally had leaders in the failed node. And as you can see, there are 2 leaders in zone A in this diagram, as the follower in zone A has now been elected as a leader. Only the connection to the failed nodes, which will have to wait till TCP timeout, and other new connections and to other nodes will be operational within 3 seconds. So that's why we like when this happens, like now all the tablets have leaders, and the system is back to normal right after 3 seconds, and there is no data loss as the data was up to date in the follower. We'll go through a demo also a little bit later, and I will showcase this in the region scenario where like how we achieve this RPO of 0. And the election process makes sure that only the follower with the latest data gets selected as leader, and Raft replication ensures that at least 1 replica is up to date. So RTO is 3 seconds because the system is fully operational within 3 seconds. So let's go over the timeline, recovery timeline. So from the point the zone outage occurs, it takes about 3 seconds for all requests to succeed. And because of that, there might be some TCP timeouts, failed app connections might take like up to 10, 15 seconds, right? So if by, one other key thing which Yugabyte will do it behind the scene is, if by 15 minutes the failed nodes don't come back online, new followers are created to guarantee the RF factor of 3, because the tablet leaders, tablets which were present on that failed zone, they are kind of unreplicated. They are under-replicated. So key thing when this zone failure happened is no data loss, system fully operational within 3 seconds, failed connections will reconnect and like in 15 seconds, and fully replicated if your node or zone has been out for 15 minutes. And by the way, like all these time limits are configurable. So we have the G flag where you can decrease or increase these time frame as well. So similar, very similar concept applies from the region failure aspects also. But let's quickly go over it. Like consider a scenario where you have deployed a database across 3 different regions, West, East, and Central in this diagram. And let's say you have set up your leaders in East, that is your primary region. And let's assume that you have set up a standby app in Central as your failover region for both your application and database. So users go to your app via router or load balancer, which would point your active application in East. Now, when the application does the write, the leaders replicate to both the followers. And as Central is closer to East than West, the followers in Central will acknowledge the write faster, so the follower will be up to date. Only after this, the write is acknowledged to the app. And let's consider the scenario where your US West region fails. And there were no leaders there. Availability in not affected by this failure at all. But there is still one follower active for replication to continue correctly. And there is no data loss and there is no recovery needed in this scenario. Let's consider another scenario where the US Central region fails. Now the replication has to get an acknowledgement from a farther away region as the follower is active only there. So system continues as usual, but this increases the latency of writes. So there is no data loss and no need for recovery. Now let's see what happens when your primary region fails. That was US East. And let's say that you have set your second preferred region to US Central. Now there are no leaders active as all your leaders were in the US East. So within 3 seconds, which is our standard RTO time, the leaders get elected. Apps can connect to the nodes in Central and West to operate on the cluster. The cluster is fully operational at this point. And the standby app in the US Central becomes active. The router starts redirecting the user request to the app in US Central. And if you choose, we have built our own smart driver for Postgres and for SQL. So it is, the good thing is like it's aware of the topology of the cluster. So if the app is still running, it will immediately redirect the request to leaders in the US Central. There won't be any redirection needed from the router in this situation. And so what we saw here, like no data loss, similar to like system fully operational in 3 seconds, app failover to next preferred region. And we talked briefly about the smart driver for automatic failure as well. And now what we'll do is, today morning I recorded like a 2-minute demo. Usually I like it doing real time, but because of the time constraint, I recorded it, and let's go over it. Let's play it. So what I have done here is in this demo, there is a 3-region cluster which I have set up. As you can see, it's in Virginia, Ohio, and in Oregon. And so simple 3-node cluster is spreading across, and I will be showcasing what happens through this workload simulator, which is in-house app we wrote to demonstrate how a database changes, like they affect the latency and throughput. So I have already created the tables. It's a simple application running, and what I will do is I will start with 48 threads or so, and start this simulation. What it's doing behind the scene right now, it's doing the when I start it up, you will start noticing that there will be some read and writes going on, and you will see what is my throughput, what is my average latency looking like. Ignore that completed and those sections because I wanted to give a time frame to start that, and so I will let it run for a few seconds, and after that, what I will do is I will fail over, like I will go and kill that entire region of on the west side. So Valerie was showing about the API calls, right? So we are truly cloud native. All this, every operation is through API call. So what I have done in this application, I'm calling this, I will make this a REST API call after selecting this and killing that whole region. And as my time progresses, like within few seconds, you will see that that whole region will go down. There might be slight increase in latency and slight for a couple of seconds, and then the application will go to the normal. So this is what I'm showing, like, hey, my operation is stopping the node which that API call which I made. And so you see now that whole region is gone. But if you look at the impact on the application, it's there is a spike in there, like which showed for a couple of seconds my latency was high, my throughput went down, and then it immediately caught up. So that's just want to demonstrate the power of like how Yugabyte can achieve this ultra resilience. And let's go through. We have talked about it a little bit earlier, but what we'll do now is we'll cover. You might be curious what went under the hood. I briefly touched upon it, but now in next few slides, I'm going to go touch upon architecture and go a little bit deep onto it. So on top, you will notice that we have this pluggable query layer. You can, if you're bringing your application from Cassandra, you can use MySQL API layer. And if you're coming from Postgres or from SQL, from Oracle, you can use the MySQL API layer. And then in the middle, which is our bread and butter, this what we call dog DB layer. This is responsible for, this is what distributed is transactional storage layer. And this is the thing which is responsible for automatic sharding, load balancing, distributed transaction, and it uses the Raft consensus. And a beautiful thing about Yugabyte DB is that you can deploy it anywhere. You can deploy it on premises, you can deploy on cloud, and Taylor in his talk talked about Yugabyte Cloud, also Aeon, which that's another managed service you can use. Let's briefly touch upon the high-level architecture under the hood. So in this diagram, you will notice that there are some YB master processes, and then there are YB T-server processes. So think of master processes as they're responsible for managing shard metadata and coordinating the cluster-wide operation. These will, when you add, in this diagram, I'm showing only three different nodes, but let's say you had 9 different nodes, an RF of 3. So there will be only 3 masters in that situation, 1 master leader and 2 follower. And but there will be 9 YBT server process, 1 on each node. This T server process is responsible for storing and serving the data and from the tablets. And in this diagram, I'm briefly showing that blue color one in the T server is the leader, and the other ones are follower. You will notice that they are very, very equally balanced. And we'll go a little bit, cover the basics and go over it a little bit more. So let's go touch upon some basic concepts here. So let's say I had a table, and when you create a table in Yugabyte, what will let's say I have three nodes in three different zones. What we'll do is we'll take a table and split the rows into groups, and each group is referred to as a tablet. Many people like calling it a shard, but we refer it to as a tablet. And this sharding, by the way, is transparent to the user and is performed automatically by the Yugabyte database. Like, you don't have to do anything manually for this. And now we have this table broken down into smaller row groups, and we are able to spread these row groups across multiple nodes. So by default, this sharding happens on hash, but we do support range and list sharding as well. Now since what our load balancer has done is that, like if you look at this diagram in here, so it makes sure that these row groups or tablets, they are evenly distributed across the three different nodes in our example. So in this example, I'm just showing 6 tablets by different colors, which are like two per each. But in the real production deployment, there will be many tablets per node, like 10, 20, 30, or actually more, so depending on the size of the table. And one key thing I want to point here is that each row will belong uniquely to one tablet. And let's see, just want to touch upon a little bit on the raft consensus algorithm here. So I have this three different nodes, and this tablet, there will be one leader and there will be 2 followers in here. The leader election can change dynamically. It will change dynamically over the course of as the time progresses, right? So so it's like a tablet leader and follower concept is important. We'll talk a little bit more about this in coming slides. So far, like. So let's see how replication happens in this 3-node cluster. In this examples, we have tablets which are spread across 3 different nodes. Solid outlines, which you see, the solid color ones are tablet leaders and their followers. So for example, like you will see on node number 2 has a yellow and pink tablet, which are solid, which means that they are leaders, and they will have the followers in the other nodes. So those dotted yellow and dotted pink guys. And so whenever read and writes for a particular row which will be happening, will always go to this tablet leader, which Raft has elected for you. And when reading the data, tablet leader will serve it right away. When you're writing the data for this particular, for example, for this yellow tablet, what will happen is that it will replicate using Raft to both followers and wait for the confirmation from the majority of the nodes before it commits this data. So Yugabyte DB will ensure that these tablet leaders are also uniformly distributed across the different nodes. So we can utilize all the nodes equally in the cluster and provide you with the best throughput. Now, coming to our example where I failed the node, right? Like so let's see how Yugabyte tolerates this node outage, how it achieves the RPO of 0 and RTO of 3 seconds. So in this particular diagram, which I have for these 9 nodes, node number 4 on the zone B, it goes down, and so it had two tablets in this example. Like one was a yellow leader, and the other guy was a purple follower. So what will happen is Raft will re-elect a new leader within 3 seconds from a different zone. For example, in this node number 2 in this diagram, it will re-elect the yellow leader. So for follower tablets present on the failed node, there won't be any impact because purple leader is already present on a different node, and that takes all the reads and writes anyway. So you won't see any impact for the data which was present in there. And there won't be any data loss since the yellow tablet leader dies and won't be replicating any data. After 3 seconds, when this new leader will be elected, it will start taking the writes. So it's very, very critical for the application as the folks who are coming from the application side of things to have some sort of like a retry logic built in your application. So if there was some transaction in flight, and it takes 3 seconds of RTO to shift the leaders. So you will do a retry after a few seconds to re-execute the transaction, because there will be some transactions which can potentially fail in here. And now let's say our node 4 has been down for 15 minutes and it's not coming back anytime soon. It happened in the night. Nobody is there to monitor or support it. So what Yugabyte will do is, like, automatically it will create the additional tablets on different nodes for both yellow and purple tablets. So this is, again, this is all automatic and you don't need to do a thing here. And once the node 4, like next morning, people, SRE team comes in and brings that node 4 back. So Yugabyte will once again go and transfer the tablets to node 4. And it's the responsibility of the DBMS to ensure that tablets are always evenly balanced. And you may ask, why wait 15 minutes? So there might be some situations like when you are doing your regular rolling database or OS rolling upgrades, right? So that's the reason we default it to 15 minutes, but this is configurable. Like if you want to increase it or decrease it, that's certainly possible in Yugabyte. And I've given the example like with respect to a single node, but similar, exact same concept applies for the whole zone going down or the whole region going down. And in my demo, I showed you like how my entire region went down and there was literally no impact to application. And when on recovery, when the zone comes back, your nodes will automatically catch up and rebalancing will be done in there. So similar, very, very similar concept applies to horizontal scalability also. Like when you had 3 nodes in this diagram, I make it, I go and I add 6 more nodes. DBMS will automatically go and rebalance all these tablets for you without any manual intervention. So if required, it will split the tablets and do that rebalancing for you. So running close on time. So, but it's for the periodic maintenance, I kind of briefly touched upon it. It's like a very similar thing whenever you're doing OS upgrades or you are doing your database upgrade, you can do it in a rolling fashion without literally any impact to your application. So just some final thoughts, like as you saw, like, and you might have experienced in your own workplace, that region and zone failures are common. They happen from time to time, and the resiliency is a first-class feature now. So Yugabyte provides you with multiple options for giving you resilience or ultra resilience, and failovers are simple and seamless. Service interruption is minimal to null. Like as we saw, like within 3 seconds, you can have it up and running. So this was my talk. I will a few minutes. I will take any questions.
All right, folks. Oh.
Hi. Thank you for the great talk. It was really good. One of the ways in which we avoided blackouts in our application when we are on AWS is that we had a failover on a different region, basically a new instance of RDS running.
Okay.
And we have a small application that runs on Kubernetes, which kind of checks the health status of each one and then directs the SQL queries accordingly. That is a very primitive way in which we made the failover work for our application.
Yeah.
It worked great, but then the downside was the speed of our transactions went down because we were waiting on both the transactions to finish and then come back. So it was, let me put it this way, the throughput of our application, overall throughput went down as the availability went up. Hearing but you were explaining the internals pretty well. So my question to you was, when you use raft consensus and have a leader and a follower, and you do something similar on your side too, how can you give me a little bit of overview on how you manage the transaction speed and how much data can be ingested per transaction when we have the data being copied to the followers?
I see. That's a great question. Network latency does come into play, and topology also matters in this case. So your situation was multi-zone or it was multi-region?
Multi-zone.
Multi-zone makes it much easier because then you are looking at the network latency of a couple of milliseconds, for example, in here. So best thing, like when I was going through some of the internal diagrams, you might have noticed that like when you throw more nodes to a cluster, so your throughput will automatically go up, like, and all your nodes are equally participating. Meaning, I am running at the example which I was showing in my demo. I was running like 2,000 something per second, right? TPS. And if same cluster, if I were to go and add 3 more nodes, so you will notice that my throughput goes to 6,000. It scales linearly as I put in more hardware. And we have several customers who are running like 600, 700,000 type TPS. It really depends on the cluster size. More you throw, it's CPU bound, right? Like more CPU you throw it at it, it will you can linearly scale the throughput. So, and the best thing is like it's all. You don't have to, like, you presented your own challenge, right? Like you have to do this trickery, and I used to do it too. Like in my previous with my previous databases, with Yugabyte, like it's all seamless. So you just plug in your app, like let DBS take care of DBMS take care of this. So
one more question. Is it okay if I ask second
please
question?
do.
So another problem that we had, it was a MySQL database, is that when we had to update our schema, we used tools, and when the update was happening, there would be no transactions, so the transactions would fail. That's the default way, right? So we used tools from Percona to kind of help us get through it. So we had our own custom process that runs, which updates the schema. It's a very so I'll not go into the internals how it does, but it's not an efficient way to do it.
Okay.
Definitely not an efficient. So you noticed briefly about rolling updates.
Yeah.
Can you speak a little bit about the transaction performance of a real-time application while the schema update is happening?
So schema update is that's a good question, and it's like it's an ongoing challenge. Like doing if you are making some changes in the live application, that is something we do encounter some minor issues on that on our side as well. It's like but as our new releases come in, like they are constantly fixing those issues. But that is a challenge which you will face probably with most distributed environments. It's not a straightforward thing. So it's still time to go for that. So
thank you very much.
Sure. Any other questions?
Oh.
Hi. You mentioned that you use.
Introduce yourself and then.
Okay. I'm Shreyas from SAP Labs. You mentioned that you use Raft for leader election. Do you also use Raft consensus algorithm for transactions as well? Let's say for write operations.
So what happens is when you are whenever you are doing a write. So as I was showing in my diagram, right? So wherever is your tablet leader, write will go to that. And this guy will be responsible. This will use the Raft algorithm to replicate the data to followers. It will wait for the majority. Meaning, like if I had a RF of 3 in my example, any one other guy acknowledges, it will say, okay, I have the majority consensus. I'm going to commit this data and tell the application your data is committed. Now let's say that you can lay out like Yugabyte in RF 5 or 7, right? So if this was a case of 5, then it will wait for majority will be 3 in this case. So it will wait for 2 other tablets to acknowledge and in that situation.
Right. So if that's the case, then when you mentioned that you throw more nodes at the cluster, essentially the throughput goes up, but essentially wouldn't the latency also go up at the same time
So
for
no,
writes?
So what happens is latency. Latency is a form factor or more of like a network, right? So throughput, how throughput will go up. I'm throwing more CPUs at my workload basically, right? So I'm giving the ability for application to have more connections in there and providing more horsepower. So when I add from 3 nodes, I went to 9 nodes. So I'm giving you more number of threads, more number of connections to do your workload. So that's how we kind of ramp it up. And it's like in my test, like I've been, this thing has been, I understand from where you're coming with, like some other databases where you might have seen that you throw new nodes to it. It's not linear in fashion. Like their ROI might go up and then it becomes constant, or like. But with Yugabyte, like in my test, like it has been very linear in that fashion. So.
Okay, that's great to hear. Thanks.
Sure.
Yeah, if you remember the demo that, I don't know if Karthi actually showed it in the morning, but one of the things we show is as your client load goes up, application load goes up, if you throw nodes, you see that with a slight lag, you start picking up again and the system is able to handle it, right? So the capacity goes up, and then when you spin it back down, again, you drop back down, right? So that's a demo. In fact, if you swing by our booth, M11 at the show floor, they actually have that demo at the booth, okay? So it's definitely worth checking out. It's a good question, though.
Hi, my name is Rais Pasha. I'm from Rising Wave Labs. Nice talk. You talked about RPO and RTO, right? Say, are those tunable? Like, for example, where I'm willing to sacrifice some resilience for the sake of cost. Is that tunable or is it fixed with Yugabyte architecture?
No, it's tunable. So you can increase or decrease that RTO of 3 seconds. So as I mentioned, right, like it will do two hops every second. So by default, we put it like a 3 seconds, and but you can increase it or decrease it. We have these knobs in our database, what we call G flags. So there are a couple of G flags you can modify to change this value. And good question.
Awesome. Any final thoughts, questions? One more.
Hey, my name is Vishnu. I'm a software engineer. So one last question. When we execute a query on a regular database, the first thing I usually do is to get the query planner running, run the explain statement, and see, according to the size of the data and what I'm doing, I try to play with it a bit so that I know what to expect in production. Owing to the distributed structure of YugaDB, how does the explain statement change?
What we have done is like we took the Postgres dialect, right? We have kind of enhanced it. So when you do explain, you can add a dist also in there, and it will show you the exact details, like whatever you are familiar with seeing on the Postgres side or MySQL side of things also. So you will get like an enhanced view of I explain from compared to the traditional systems. Yeah, it's very powerful. Have you used Yugabyte before?
It was something that we had in our plate, but then due to some business reasons, we could not use it.
You should bring it back to the plate. Yeah.
Awesome. All right. Thank you, Amit.